In this example, we're going to model two eyes in a system where the eyes are looking at an eye chart. One eye will be different from the other, so we will have two distinct retinal images. So here's our two eyes looking at an eye chart. So let's load AHEM and see how we would do this. So I have a settings file, and I'm going to load. Click OK. Here's my basic setup, and I've got two eyes selected. I'm going to use the AZ eye model for both eyes. So my setup here is for a target. I'm going to use an object, so I've got this box checked. And my source target grid rays will be 121 by 121. I've got an eye chart, eye chart selected for a target. If I wanted to, I could use any image that I have. I'm going to rotate 180 degrees to look at it so that the inversion caused by the eyes will be upright. And I've got a retinal image window set and some display pixel settings and some other standard settings. I click OK. And now I get prompted for information about both eyes. I've got a standard interpupillary distance of 55 millimeters, some vergence, and I've put 5 diopters of axial ametropia on one eye. So I've made one eye longer, giving it myopia. So that one will have a blurred retinal image compared to the other eye. So the rest of the settings I kept the same. And I click OK. And I've also got one diopter of accommodation on both eyes' lenses. So the target is at 1 meter. So I'm going to accommodate both eyes 1 diopter. Yet one eye is going to be longer because I put 5 diopters of ametropia on it previously. So all the other settings I'll leave alone. And I'll click OK. And here's my second eye. And here's just the 1 diopter of accommodation, just like eye 1. I click OK. And begin to trace our rays. So we see rays going to both eyes. And we're looking at an overhead view of the eye chart here. And rays starting from it and going towards the eyes. You can zoom in here and see those rays entering our eyeballs. All right, so we've got our data generated, and I can look at some of the information here. Let's take a look at our display. And we've got eye 2 on the left and eye 1 on the right. So notice eye 1 was the eye that I did not put ametropia on. So this is the correct eye or emetropic eye. And then the blurred eye or the myopic eye, where I lengthen the retina or lengthen the axial length, is the blurred image. So if I was inclined, I could also free fuse these images and I could see the three-dimensional stereopsis associated with these images. I can look at each image individually. So here is the clean corrected image from the emetropic eye. And here's eye 2. You see it's blurred from the myopia that I induced from putting 5 diopters of axial length from the ametropia. This is just another way to view images. I can change the palette, so I can use a grayscale or a color scale. I can have various ways of looking at my images. Down here in the chart viewer, the cross sections don't make much sense because we're taking a cross section through letters of the alphabet, and neither does the retinal encircled energy because we're looking at a wide field now. However, if we look at the overlapped retinal images, we can see that there's much more energy in the corrected eye than, which is the red eye 1, the solid series, and eye 2 is the dashed green line, which has much less energy in it. So once again, we can model two eyes with independent optics and independent aberrations from each other and create images that are respective to both eyes, and we can free fuse them if we wish.